to be talking about Euler's method. So the equation for Euler's method is yn plus 1 equals to yn plus h f prime xn comma yn. Okay, so the h over here is the step size. So Euler's method is basically using a graph, using a table to find an estimated value. So this is a table that you have to draw. And n over here is basically the position value. So it's going to be from 1 going up. So like 1, 0, 1, 2, 3, 4, 5, 6, and so on. And then x is going to be the x value, which is going to be changed by the step size. Okay, and then y is over here what we're trying to find, which is going to be the estimated value using Euler's method. Okay, and the question over here is given that dy dx equals to x over y squared. And then when x equals to 0, y equals to 1. And then we have to find the approximate value of y when x equals to 1. Okay, so we have to find the approximate value of y. So I'm going to be using Excel to show how this table is going to look like. Okay, so I'm going to have n and then xn and yn. And then these are just two additional to just show you how to use the Euler's method. Okay, so I already done most of the calculation, but I'm just going to fill in the blanks for when n equals to 5. Okay, so over here, we're going to be using the step size of 0.2, so h equals 0.2. And because of that, all the x values are going to change by 0.2. Okay, in the question also is given that when x equals to 0, y equals to 1. So this is the initial value. So this is when n equals to 0. So we can fill this in when n equals to 0, and then this is 1. Okay. So then using Euler's method, over here, Euler's method, we can find each value when n equals to 1, n equals to 2, we can find the estimated value. So I'm just going to show you when n equals to 5, because every step is the same. So xn, since the step size is 0.2, is going to be changed by 0.2, so this is going to be x equals to 1. And this is what we're trying to find over here. X equals to 1, what y is. Okay, and then to find y, using Euler's method, we have to find what this value is, f prime xn comma yn. And it is given in the question that dy dx equals to x over y squared. So we can just use this equation. Okay, so looking at this, when y equals to 5, the n over here will be 4. So that means we have to use x4 over y4 squared. Okay, so over here, we'll just do this, x4 over y4 squared. Okay, so then this is the dy dx. Okay, then we can finally use Euler's method, which would be so this would be y5 equals to y4 plus h times the dy dx. So this is y4 plus h 0.2 times this value, and we'll get 1.31. Oh, sorry, 1.32. So over here, will be 1.32. And then to find the approximation error, we have to find the actual value, because this is just an estimated value using Euler's method. So you have to find the actual value. And to do that, we have to find the original equation. So I did the simple manipulation and integration over here. So I managed to get subbing in when x equals to 0, y equals to 1. So I found C, and then found the original equation over here. So it becomes y equals to the cube root of 3x squared over 2 and plus 1. So over here is when I sub in when x equals to 1, because that's the question, that's what we're trying to find, x equals to 1. And the actual value turned out to be 2.144 over here. So I did the same for all the other values. And then to find the approximation error, I basically just took the actual value minus yn, so 2.14 minus 1.32 to get the approximation error of 0.82.